Hello, I'm Richard Hooper and I'm pleased to be joined by Danny Seacrest, Senior Business Development Manager at Teledyne e2v. Hello, Danny.
Hello, Richard. Good to see you again.
And you. Now, just a few weeks ago, you announced another new RF product, a 25 GHz MMIC frequency doubler. What's so special about the product and what are the key advantages it brings to the applications people are using it for?
We had a driver customer that a big defense geostationary satellite developer company that we work with quite frequently that needed a frequency multiplier. In this particular case, they needed a frequency doubler. They were designing an up converter, if you will, a frequency synthesizer up converter. They've got on the satellite, they've got their data processing engine, and then when they get ready to do a downlink, they were needed to downlink to a Ka band. And so what they need to do in there is to have a frequency doubler that can drive the mixer in the system, in the synthesizer, with a appropriate signal. So typically they're not bouncing around Ka band signals inside the satellite. So they have a data engine that's putting out an IF band, intermediate frequency, and then what they need to do is convert that to a Ka band frequency for the satellite downlink. And so what they do there is then they use this kind of a frequency doubler to double the input frequency so that it drives the mixer and they can do the appropriate modulation scheme for their satellite downlink. Now this particular product we developed in conjunction with them to meet their specifications, their requirements, the reliability testing and screening for the satellite application. They chose both of our mixer we announced earlier this year and this frequency doubler for this particular frequency synthesizer that they were developing.
Now, just expanding on that a bit. So for those space engineers and designers out there, are there some key features that would interest them most?
Well, in looking at this product in particular, they needed obviously a device that would handle the robust aspects of space. And so typically one of the first things they're going to ask about is what's the radiation tolerance? We like the device, what's the radiation tolerance? Will it handle a very long-term geostationary satellite application in a bird that's going up for the US government that's going to be a very high value? And so this is a device that meets that requirement, being a gallium arsenide based device is capable of well over 100 K-rad TID tolerance. I think they even went and did some additional testing on their own, but that's kind of the first step in the process. Is the part capable of meeting those specs? And then they start looking at other aspects of the product. Does it meet the frequency range? So this particular device, you can put an input signal anywhere from 7.5 gigahertz to 25 gigahertz, and that yields you an output, a very broad output frequency range for driving the local oscillator input into a mixer of anywhere from 15 gigahertz to 50 gigahertz. And so a very broad frequency spectrum. And so this meets all the characteristics there. In addition to just being able to multiply or double the input frequency, this product also has an active amplifier in the output stage. It's a it's a distributed amplifier, buffer amplifier that takes the signal and then amplifies it and can drive upwards of 15 dB of maximum output power into that local oscillator. And so it makes it a very good device for that kind of an application where it has that kind of output power drive. If you look at the architecture of most frequency multipliers, these are you'd really call it a harmonic distortion engine. And how you get the frequency doubled is, think of it in terms of harmonic distortion, right? You have an input signal and you have a second harmonic, third harmonic, fourth harmonic. Since this is a doubler, it keys in on the second harmonic, which is 2 times the fundamental frequency, and amplifies that second harmonic, and then tends to filter the fundamental carrier frequency amplitude and the subsequent harmonics. And so this part is designed to be a frequency doubler. It amplifies that. So the output signal has a 13 dB gain on the fundamental, on the second harmonic. So you have 13 dB of gain there. And then it does a filtering. It filters the fundamental frequency by about 20 dB. So then you get your really nice frequency double frequency at the output, and you reject all those other signals so that it's very useful as a frequency doubler. Now, we also make this part available in die form because it's, being 50 gigahertz, it's very difficult to get a packaged variant of this kind of a multiplier in a hermetic package for space. So it's offered in a die form. It has passivation on there to protect the device, has backside gold metallization so that customers can mount this via eutectic die attach into their module, or they can use a conductive epoxy, thermally conductive epoxy, like a Namix type epoxy in their particular scenario. And so that makes the part lend itself very well to manufacturing. And then I think last of all, what makes this a desirable product is we've qualified this die and the wafer to the MIL PRF 38534 Class K element evaluation scheme. And everybody that purchases die and use die for space applications are very familiar with this space qualification standard. It means the product and the wafer's been qualified with a 1,000-hour live test, and we've done the burn-in. All of the die on the wafer are 100% tested for RF output power, the DC characteristics, and then we can also, for each individual die, have the space visual inspection to MIL standard 2010 space standard.
Well, Danny, it's interesting times. Thank you for giving us an update, and look forward to speaking to you again soon.
Thank you, sir. Have a great day.